Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 102, binary tree level order traversal. So for this problem, you're given the root of a binary tree and you need to return the level order traversal of its nodes values. So that is from left to right, level by level. So the level order traversal would be the first level, which is 3. There's only one thing in that level. And then from left to right, so next level, so this is the first level, this is the second level, this is the third level. So from left to right, the next thing is 9. The next thing is from left to right is 20. That's the next thing in the second level. So we finished the first level, the second level, and now the third level, 15 and 7. And so that's the third level, and then we're done. But we actually want to group the levels together in an array. So, group the things in a particular level in an array. So the whole thing is an array, but each level is grouped. So 3 is a level by itself, so it only has one thing, and 9 and 20 are in a level, so they're grouped together, and 15 and 7 are in a level together. So ultimately, you can see that this matches the expected answer. So you can see how to do this if we're just looking at the tree. You basically you start from the top and you go from left to right all the way until you get to the last level in the tree and there's no more nodes. But how would you do this programmatically? Well, this is a breadth first search question because level order traversal is the same as breadth first search. For breadth first search, you use a queue data structure. So you know that for depth first search, you use a stack data structure. You either use the recursive call stack or you use an actual stack that you've allocated to do depth first search. For breadth first search, you use a queue and you do it iteratively. So we can make use of a queue to do this, and we can also keep track of the levels since we need to do our output, group our output by level. We can keep track of the levels. So let's use a queue. So we're going to have a queue. And what we're going to do is we're going to put our root in the queue, and we're going to put the node value, which is 3, and we're also going to put the level, which is 1. So we're going to put a tuple in the queue with the node value and or the node, or just the node and the level. So we put that in the queue. Now we actually pop from the queue. So when you or you dequeue from the queue. So when you add to the queue, you add it. So it's a queue is a first in first out structure. So you put this first thing in the queue, and then you remove it from the queue, you pop it from the queue, and you see that it is a 3 and a 1. So what you do is you add the 3 to your array that you're keeping track of, all of the things in that level. So you add the 3, and you also add its children. So you enqueue its children. So you put a 9 in there, and you put the level for the 9, which is 2. and you put its other child, which is 20, and its level. So now you try to see, is there anything else in this queue? Is the top thing in the queue, the next thing in the queue, does that have a level of 1? No, it doesn't have a level of 1, so we're done with the 1 level. So in our result, we're going to have the first thing in our array is just going to be that 3. Now we're going to run our loop again. So we're going to pop we're going to dequeue the first thing that we had put in our queue. So that's the 9 and the 2. So we pop this and we add 9 to our level result, and then we add its children. So 9 doesn't have any children, so we don't add anything. And then we go to the next thing in the queue. So we pop this out of the queue. So now we have 20 and 2. So we add a 20 to the level, 9 and 20, and then we add its children. So 15 and 3. 15 is at level 3, and then 7 is at level 3. And now we look in the queue and we see, is anything in this queue need to be popped from the because it's in level 2? No, because this is in the first thing in the queue is in level 3, so we don't pop anything. So we can take this 9 and 20 and add it to our result. So now our result is 3 and then 9 and 20. And then finally, we we go to our next level and we pop our 15 from the queue. So we pop this, and then we add this to a new level, 15, and then so we add 15, and then we add its children. It has no children, so we don't need to add anything to the queue. So then we pop again. We pop this 7 because it has a 3 level. So we pop this 7, and we add this to the level result. And then there's nothing left to pop, so we just add this to the result. So we do 3, 9, 20, 15, 7. And we've got our answer. So that is the algorithm for solving that problem. So now we're going to do this with code. So let's see how to code this up. So the first thing we need is we need a queue. So we're going to use the deck data structure in Python. So from collections, import deck, which is basically a del-ended queue that we can use. So we're going to say queue equals deck, and we're going to give it the first thing in the deck. So we're going to give it the root node and also the level of the root node, which is 1. so we're giving it a tuple. And then we need a variable that keeps track of the level, so we're going to call that I, and we're going to start it at 1. And we're going to do a while loop, while the queue is not empty. Then we're going to run this loop, and for each thing in the loop, we're going to have also run for each thing. We're going to also run another while loop. So while, and we're going to run this loop while our first thing. So while we have something in the queue, and that thing in the queue, the first thing in the queue, which is the queue at 0, and it's in the tuple, the second thing in the tuple, which is at index 1. So this is the level. So while this level is equal to I. So I is going to be 1 starting out. So this loop is going to run until we finish everything in the first level, and then we're going to increment it. So before we run this, we're going to have a level array. This is going to keep track of all the elements in the level. So we're going to add this, and we're going to have a result array for at the end, and the result array is also going to be empty to start. So while there's something in the queue, and the first thing in the queue is the same level as the level that we're trying to process, we are going to pop from the queue. So we're going to say node and j for level is going to be equal to stack. It's not a stack, it's a queue. Queue dot pop left. So we always pop left from the queue. And so this is going to give us our node and our level. So what we're going to do with this is we're going to say if node dot left, if it has a left child, then we're going to append this to the stack. I mean, not to the stack, to the queue. So we're going to do queue dot we're going to do queue dot append. So we're going to append, and what we're going to append is a tuple of our node dot left and our j, which is our level of the node that we're currently on, plus 1, because its child is going to be lower at a lower level than the parent, the 1 level lower. So if node dot left, we're going to queue dot append node dot left, and if node dot right, if there's a right child, we're going to queue dot append. Whoops, this should be like this. Node dot right j plus 1. Okay, so we've appended the children to the queue, and now we're going to process the node. We're going to add it to our level. So we're going to say node, we're going to say level dot append, node.val, and that's going to put the node value in the level array. And now we are done with that while loop. So once we break out of the loop, we're going to need to increment I because we're going to go to a new level. So we're going to increment I, and we're also going to append what is in level to result. So result dot append our level. And that is, then we just return our result, and that should be the code. So let's run this, and it's giving us the correct answer. So let's submit, and we're getting a bug. None type object has no attribute, no dot left. So we should say oh, this is for an empty array. So I mean an empty. So if we're given an empty root, then what should we do? So this is an edge case of if we're given an empty root, what should we do? Well, if this is empty, then we should return. We could just have a catch all right at the beginning. If not, root return an empty array. And we can do that. And there we go. This is accepted. So that's one way we could handle that. We could also handle the edge case other ways, but that's one way we can handle the edge case. So thanks for watching. This runs in, so you have to process each node once. So this will run in O of n time, for n being the number of nodes in the tree. And you also have to put each node in the queue once. So it would be O of n space. So thanks for watching, and I look forward to seeing you in the next video.